Good evening, my YouTube viewers. In this particular video, what we're going to do is we're going to do an A/B test on an email campaign. And so the question that we're going to ask is, does a personalized subject line in an email campaign result in higher open rates compared to a generic one? And what we're going to do is we're going to write a program in Python to answer this question. So when we write the program, what we need to do is we need to import the libraries that we're going to need to actually answer the question. But as I look at the libraries, I can see that one of the libraries doesn't look like it is written in the code, but I think that because the library is elsewhere in the computer program, it went ahead and accepted it, because basically what I did was I did one Jupyter notebook. No, the library is there. Never mind, I was wrong. I did one Jupyter notebook, and each program is written in a cell in the Jupyter notebook. But the library is there. I just didn't look like it was there on first inspection. But as I look closer, I can see that the library is there. So what we're going to do is we're going to go through the libraries that we need to import to be able to execute the program that we're going to write. So the first thing we're going to do is we're going to import NumPy as NP, which is a numeric library that also can create NumPy arrays. And then secondly, we're going to import matplotlib.pyplot as PLT, which is a visualization library. And thirdly, from scipy.stats, we're going to import chi-squared contingency. So scipy is Python scientific library. Stats is a statistical module within SciPy, and then chi-square contingency is a function within the statistical module. So after we've imported the libraries, then what we're going to do is we're going to simulate the data that we're going to use. So the first thing we want to do in that regard is we want to set the seed. And the reason why we're going to set the seed is so whenever we run the program, it will always initialize to the same values. And so the program will always run the same every time you run it. So you set the seed by typing np.random.seed, and then you can put any number that you want inside the brackets. And total emails equals 1,000. So that means we're going to have 1,000 emails. So we're going to have group A, which is the control group, and it's got a generic subject line. So group A emails equals total emails floor 2. So you're going to round down to the nearest digit. And then group A opens equals np.random.binomial, and binomial means a binomial distribution, and a binomial distribution means you have two outputs like yes, no, 0, 1, true, false. So that's what a binomial does. It gives you two outcomes, possible outcomes. And then it's the binomial brackets group A emails, comma 0.15. So 15% open rate for a generic subject line. So this is just data that we have synthetically created. And group B is a personalized subject line. So this is the variant group. So group B emails equals total emails floor 2. And then so that's going to be 500 really. If you've got 1,000 emails, 1,000 floor 2 is 500. And then group B opens equals np.random.binomial brackets group B emails, comma, dash 0.25. So that means 25% open rate for personalized subject line. So this is just synthetic data that we have created. So we're going to create a contingency table for the chi-square test. So data equals NP array, and the first column is group A opens, comma, group A emails minus group A opens. And that opens and non-opens for group A. And then the next column is going to be group B opens, comma, group B emails minus group B opens. And that opens and non-opens for group B. So your group A is your control group and your group B is your variant. And so now what we're going to do is we're going to perform the chi-square test. So chi-square, comma, P, comma, underscore equals chi-square contingency data. So we're going to print the test results. So we're going to print the group A open rate generic and group B open rate personalized. And we're going to print the chi-square statistic and the p-value. Okay, so come over here to the bottom of the cell. So you've got your A-B test results. Group A open rate is 14.40%. That's the generic control group. And group B open rate is personalized is 25.40%. And that's the variant group. Your chi-square statistic is 18.294 and your p-value is 0. And then so because the p-value is 0, it is less than 0.05, which means that the null hypothesis would be rejected. But we will go back to the program where we left off. And then so if P, now P is your percentage. If P is less than 0.05, the result is the difference in open rates is statistically significant, which is what it was. Otherwise, there's statistically no significant difference in the open rates. But since P was less than 0.05, the difference in open rates is statistically different. So now we're going to plot the results on a graph. So labels equals open or did not open. Group A data equals group A opens, comma, group A emails minus group A opens. Group B data equals group B opens, comma, group B emails minus group B opens. And X equals NP dot arrange len labels, and that's your label locations. And width equals 0.35, that's your bar width. Okay, so we're going to make a bar chart. So plt.figure, fig size equals 6,4, plt.bar, brackets, x minus width divided by 2, comma, group A data, comma, width, comma, label equals group A generic, color equals blue, alpha equals 0.7, and plt.bar, brackets, x plus width divided by 2, comma, group B data, comma, width, comma, label equals group B personalized, comma, color equals orange, alpha equals 0.7. So now we're going to label and annotate the bar chart. The title is Email Open Rates, Generic versus Personalized Subject Lines. X label is outcome, Y label is number of emails, plt.x ticks, brackets, x, comma, labels. You get a legend. The grid is axis equals Y, comma, line style equals dash dash, comma, alpha equals 0.7. So we're going to put some code in there to put the number above the bar for the group A data and the group B data, and plt.typeLayout and plt.show. So there's supposed to be a total of 1,000 emails. And so group A is the generic one, which is the control group, and group B is the personalized one, which is the variance group. So group A, 72 opened, whereas 428 did not open, and that's a total of 500 emails. And then group B, 127 opened, and 373 did not open, and that's a total of 500 as well. So group A, you had 500 emails, and group B, you had 500 emails. But overall, the group B had more opens than group A. So people who are making the decision on this would actually go ahead and decide to make the email personalized, because more people are going to open a personalized email than are going to open a generic email. So that concludes this video. The next video is going to be another A/B test, and I hope that you decide to watch it.